Okay, a few months back I made a video about probabilities, and I feel like a lot of people didn't understand and kept telling me I was wrong when clearly I was not. I did make a mistake about the probability of getting an event occurring more than once, um, and that was stupid, but now I can fix it. But people were arguing about me about the probability of an event happening once, which is not more than once. So yeah, um, let's try to fix it. So I'm going to fix people's opinion about everything I said in the last video for people who were telling me I was wrong. So you're gonna have to know about Pascal's triangle to understand everything I say. And you're going to have to know about probabilities, but first let's talk about Pascal's triangle. Pascal's triangle is when you start with a 1, then you had 1, 1, then you had like 1, 2, 1, and then 1, 3, 3, 1. Maybe move it like this, and then you keep going like this. And 1, 5, 10, 10, 5, 1. And I won't keep going, but yeah, basically, this pattern comes up in a lot of places. As you can see, this is 11 to the n equals 0, 1, n equals 1, 11, n equals 2, 121, n equals 3, 11 to the 3, 11 to the 4, 11 to the 5, except here, 11 to the 5, if you type it on a calculator, is going to look more like this. Am I missing a 0? Should look like this. And then 11 to the 6 is going to be even more horrible because just more digits move around because we're in base 10, but whatever. That's not what I meant to do. Delete, delete. Okay, so this comes up in 11 to the n, and it also comes up in x plus 1 to the n also. So this is going to be the multiplicator of the terms, basically. So if you have 11 to the 5, it's going to be 11 to the 5. X plus 1 to the 5, it's going to be this, plus 5x to the 4, plus 10x to the 3, plus 10x squared, plus 5x plus 1. So this is very useful, as you can see. Try doing this to the 5 in the amount of time it just took me to do it without using this trick. Even doing 11, I mean x plus 1 to the 3 or to the 4 is horrible. Imagine to the 5 to the 17. You need this. You need this. This is incredible. And another way it comes up is in probabilities. So this is why you have to know about it. So I just presented that to you. Now let's move on to a different form of it that I drew here. It's basically Pascal's triangle that looks a bit uglier and is in a grid, and instead of being a triangle like this, I just moved the top to the left. Everywhere I put the middle on the left, and instead of adding the 2 digits on top, you add the digit on top and the digit on the top left. And this is basically the same lines. So now you might be wondering, how the hell does this comes up in probabilities? Well, if you want the probability of an event happening once, and I don't know what the fuck is going on upstairs, but whatever. If you want the probability of an event, actually this is going to be 0 in our case, probably. Actually no, because this is this line, it doesn't fit. Yeah, this is, the first case is a bit tricky to understand, but the rest is Pascal's triangle. But the first one is more like 0, 1, okay? You'll understand why. So, let's say this is the let's just use for the entire video, I'm going to be talking about Runescape probabilities. So let's call this 0 whips, and then this would be 1, 2, 3, 4. This would be like 4 whips, 5, 6, 7. Oh wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. Does this make sense? Yep, it does. So okay, this is just like the amount of now you might be thinking, what the hell is this guy doing? But let me continue. So, if you kill 0 abyssal demons, um, you have this is the it's more like 1-0, isn't it? Yeah, it's a 1-0. I wanted to type, not 0-1. Let me just um, like this. Okay. So basically, if you kill 0 abyssal demons, you have 1 chance of having 0 whips, let's say, or it could just be 0 chance of having 0 whips, but I just wrote the 1 instead. I think I should just write the 0 actually, but 0 causes a lot of problems in the logic of this Pascal's triangle, but let's just put 0. You have no chance of having no whip, and no chance of having a whip. You have 0 kills. If you have 1 kill, you have 1 chance of having a whip, 1 chance of having no whip, and I meant to do it the opposite way. I meant to say 1 chance of having 0 whips, 1 chance of having 1 whip. If you kill 3, you still have 1 chance of having 1 whip, 0 whips. You have 2 chances of having 1 whips, and 1 chance of having 2 whips. And now the way you want to understand this is like this. You basically have yes, no, yes, no, yes, no. I'm sure you've seen these types of things that keep going exponentially, 2 to the x possibilities as you keep going. And yeah, this is another thing I wanted to say about it. Thanks God I remembered that. If we go back here, I erased it. If you have 2 to the x, 2 to the x, this is the sum. So basically, 2 to the 0 is 1, 2 to the 1 is 1 plus 1, 2 to the 2 is 1 plus 2 plus 1, 2 to the 3 is 1 plus 3 plus 3 plus 1, and then you can know this is going to be 16, this is 32, and yeah, I guess it can be helpful also, but it doesn't really have a use, but I like doing maths for fun, not because it necessarily has a use, but in our case, it's helpful for probability, so it does have a use. Now this might be too like pushed around, so I'm just going to stop after this one, but oh god, yeah, this is already horrible. So, yeah, actually, oh, never mind, never mind. Let me redraw this more spaced out, because this is absolutely horrible. Yes, no, yes, no, yes, no, yes, no. So, if you kill 1 abyssal demon, you can have yes I have a whip or no I don't have a whip. If you kill 2, you can have yes I have a whip and yes I have a whip. You can have no I don't have a whip, no I don't have a whip. You can have yes I have a whip, no I don't have a whip, and you can have no I don't have a whip, yes I have a whip. Basically one outcome is two whips, one outcome, as you can see right here. And then there's 2 outcomes here that are 1 whip, yes, no, and no, yes. Both are the same. This is having 1 whip, and no is having 0 whip. There's a 1 outcome that leads to 0. And as you can see, this is Pascal's triangle again. So this is Pascal's triangle in probabilities. You can have, well, this is basically, this is more like x plus 1 to the n, and this would be x plus 1, but it's y plus n. And then to the n, but n would have to change, like to the n prime, whatever. So whatever. Let's just try to understand this. Basically, whatever amount of abyssal demons you kill, there's only one way for you so that every kill gets you a whip, and that is getting a whip every kill, which is always being on the yes line. If you stay on the yes line, if you stay on this line right here, you will always have n whips and n kills. And if you stay on the no line, you will always have 0 whips in n kills. And then at some point it becomes more likely for you to switch to the yes line when you're on the no line and obtain a whip. And my argument was that on average you won't go to the 1 whip line after 512 kills. It's going to be after ln of 2 times 512. Ln of 2 is also a crazy number. Let me pull up the calculator. That's log n base 10 of 2. Um, can I do, isn't there ln on this thing? There has to be, there's no way. Maybe I'm blind. There's not even E on this calculator. What is this? What is this? There's no E on this calculator? Um, well, this isn't going too well. I'm just going to open up Google because that's going to be more helpful than this thing. ln of 2. Hopefully Google will um, maybe like this. Okay, 0.693147. And if you're wondering what that is, what ln of 2 is, let me do this. If you do e to the ln of 2, you get 2. ln is a tool that is built so that if you do ln of e to the x, you get x. This is all ln is for. And if instead of putting e to the x, you put 2, you get this value. And ln of e to the x is x, and e to the ln of x is also x. And this is quite crazy, except it doesn't go in the negative, so. Because you can't put a negative value in ln, so ln of x would be the negative value x, and you can't put a negative value in an ln, because then it would mean that e to the ln of a negative value gives you the negative value, but e is a positive constant, and a positive constant to a negative equals e to the minus like something, let's say. E to the something will always be positive. It cannot be negative. I don't know if I explained that properly, but you probably know about this already if you're watching this and you plan on understanding everything. So, basically this is ln of 2. 0.693147. This is also quite crazy. If I add, oh, yep. Uh, if I add 1 minus 1 divided by 2 plus 1 divided by 3 minus 1 divided by 4. Can I find that somewhere? I can't, but basically if you do the sum, maybe infinite sum of minus 1 to the n times 1 divided by n. I don't know if that's going to pop up. Anything? Um, well, it doesn't, but basically if you had 1 minus 1 half plus 1 third minus 1 fourth plus 1 fifth minus 1 sixth, you get ln of 2. Crazy, isn't it? If you want, if you have something you can program in and just get values from, you can put 1,000,000 iterations or 10 million, I'm not sure which one it was. If you put 10 million iterations for n from 1 to 10 millions, you get pretty close to ln of 2. I think you get this, and instead of being 18 here, you have like a 2 and different digits over here. Basically, all these numbers are the same for like 10 million iterations. So yeah. This is the value that this will converge to. Let me just ln 1 half divided by actually let me put all of this inside. Ln of 1 half divided by ln of 1 minus 1 over n divided by n. And then let's just say lim n tends to infinity of this equals ln of 2. I don't know, I haven't been able to do it properly because it's like at somewhere in here you divide by ln of 1 minus 1 over n, which is like let's say f of g of h of x, and I don't know how to derive that properly. You basically have this. I know how to derive anything like this, but I haven't been able to do this one. I don't know, maybe it's just that this limit is more complicated than I thought and I did something wrong, but I haven't been able to do it properly. But the limit when n tends to infinity of this, let me actually write this down here because that's usually how it is. And this is equal to ln of 2. Now you might be wondering, what the hell is this? This video is going to be quite longer than I thought. It's already been 15 minutes. If you want to find the probability of being on either this line, and I'm drawing, okay, of being on either this line or this line, it's really easy. All you have to do is say, since there's only one possibility, it's whatever this is. So let's say getting a whip is 1 in 512. To the, well, I don't have to put the parentheses, but I'm still going to. To the n equals chance of having n whips in n kills. Now, a lot of people are going to agree on this, so if you don't kill any, that would be, yeah, it doesn't work for any. This is another problem. If you put 0 in there, it's going to tell you your chance is 100. Oh yeah, but it's also going to tell you have 0 whips, so never mind. So if you have 0, n equals 0, you have 0 whips and 0 kills, and you have 100% chance. If you have 1 whip, I mean if you have n equals 1, you have a 1 in 512 chance of having 1 whip and 1 kill. A lot of people are going to agree on this. How could you not? The rate is 1 in 512, you kill 1 in 512 chance. And then if you kill 2, the chance of getting a back-to-back is, first, let's look at it this way. You can have 511 over 512, you won't get 1. Then 1 divided by 512, you will. And then 1 divided by 512, you will. And that was quite bad. 1. There we go. And we don't care about the other possibilities. So to be on this one, what you have to do is you first have to get 1, and then you have to get another 1. And the other 3 probabilities that would be here do not lead to having 2 whips. There's only 1 that leads to it. As you can see here, it's a 1. And then, so this is to the n. And then if you want the probability of having 511 divided by, yeah, this one I have to put like this, 511 divided by 512 to the n equals chance of having 0 whips and n kills. I think a lot of people are going to agree on this also, but then they're not going to agree on my next statement, which is going to be completely crazy, because if they agree on this, they have to agree with the other one, but they don't. So, this is the chance of being on this line right here that says you have 0 whips. There's only one outcome that leads to having 0 whip on the thing I drew. Basically, you have to stay on this line, right? And every time you kill one, you have to stay on this line of getting always landing on this one. And there's only one possibility. If you get a whip, you're no longer on this line. You no longer have 0 whips. You have to stay on this line, and there's only one way to stay on it every time. No matter how many kills you are on this line, x equals 1 or x equals 0 depending on the way you look at it, but this is x. So let's say this is x equals 1 right here. At x equals 1, it's always going to be a 1 over here. Whatever the n is, it's always going to be 1. There's only one way to have 0 whips in n kills, and it's to get 0 whips every kill. And then you want to know the how do I go from this line to this line? I have to land on a tile like this. I have to switch. So how do you switch? Well, the way you stay on this line is by not getting a whip, and the way you change line like this, or more like this actually, because you gain a kill when you change line. So every time you gain a kill, you go down, and every time you gain a kill and you get a whip, you go like sideways like this. So if you don't get a whip, you keep the same amount of whips. This is x is like the amount of whips, and n is the amount of kills. So every time n ups by 1, and if you get a whip, x also ups by 1. So the chance of having one whip is basically equal to this chance of having 0 whips times kills divided by 512. Okay, let me explain this. Basically, how do I explain this? Well, it's going to be like this. It's going to be 511 divided by 512 to the n minus 1 times 1 over 512 divided by n. And hopefully everybody understand this. I'm going to try to explain this as best as I can, but this is the most important part. If you understand this, you understand everything. This right here is the chance of staying on this line for n minus 1 kills. For n minus 1 kills, you will be on this line right here. You will be at 0 whips. And then you're going to change. Yeah, I wrote this the wrong way. I meant to do divide, but since I did times, I'm just going to exchange these. Okay. So, and then you want the chance of getting a whip, which is 1 in 512. I'm actually, this might be a bit too confusing, so I'm going to actually write it as 1 in 512. Just to the 1. Okay, and then times n. So basically, if you want to switch line, there's a 1 in 512 chance every kill that you're going to switch line. So one way you could see it is that, well, if there's a 1 in 512 chance every time, I can just multiply it by n, which is the amount of kills I've done, and that's going to work. But the way I see it is that it's this line right here. This line is equal to n, or well, n minus 1, but like, no, actually this is equal to n. This is n equals 1, n equals 2, n equals 3, and this is the amount of possibilities of you having one whip. And this is a very powerful tool if you just understand what I said. Pascal's triangle is sick. If you want the probability of having basically 18 whips, you have to find the rule for x equals 18, which I don't have, and it's incredibly hard. Basically the rule for x, let's just go right here, the rules for mathematical equations. X equals 1. Let's say f of x equals, well, this would say be like f of x and n. I don't know how to write this. Let's just write that. I've never written anything like this. Equals, well, it's actually only f of n. What am I doing? It's f of n. Basically, if x is equal to 1, let's actually say x is equal to 0. F of n equals 511 divided by 512 to the n. This is what I've written already, just right here. Chance of having 0 whips. If x equals 0, this is it. If x equals 1, what I just said was it was going to be f of n equals 511 divided by 512 to the n minus 1. Let's do it like this. Times n divided by 512. And then n divided by 512. Basically, this is actually, yeah, this is, I have to write it differently. I have to write it like this. Otherwise, it's going to be way too confusing and it's going to lose its meaning. And then what you have to understand now is that for any x equals 17. Well, let's start with x equals 2 just so you understand better. It's going to be 511 divided by 512 to the n minus 2 times. Now, I'm going to write 1 in 512 first. 1 in 512 to the 2. Okay. Now this is going to be very very hard to understand, but times n plus 1. And now it might be n minus 1 depending on if I let me just replace one number in the equation because this moves down, so I think it's n minus 1. If I say n equals 2, this is going to be 1 times 1 512 squared times 6 and 512 squared. And if I put minus 1, I want it to be equal, I want this to be equal to 1. So n squared plus n equals 1. Doesn't solve for, it solve for x equals, what am I doing? Yeah, no, it is a minus because basically what I'm doing is, yeah, I did it wrong. It's a minus here because this is very confusing to write. It's even more confusing when you try to find the rules for the other x's. Basically, this is the chance of having no whip to the n minus 2. The n minus the amount of kills. This is actually genius. Let me write it like this. This is going to be much better. X equals a. F of n equals 511 divided by 512 to the x minus n minus a times 1 divided by 512 to the a times rule for x equals a. Now the rule for x equals a is what's hard to find in here. This is the entire problem. And now I'm getting sidetracked, but um, whatever. This is what's hard to find. The rule for x equals a. And I know I'm missing a thing here, like this. Okay, so this is what's hard to find. Basically, for x equals 1, you can see the rule is 1. It is 1. So this is why here you could multiply by 1, but it wouldn't change anything. And you could also multiply by 1 over 512 to the 0, but it wouldn't change anything. So I just wrote the first term here that is actually not equal to 1. Because if I put the rule for x equals a is always equal to 1, and then the rule for this is also always equal to 1, so I don't have to write it for x equals 0. And then for x equals 1, you have 511 divided by 512 to the n minus 1 times 1 over 512 to the 1 times n being the rule of this. As you can see, these are like the possible outcomes, the amount of possible outcomes. So this is equals to n. As you can see, n equals 1, this is equal to 1. N equals 2, this is equal to 2. 3, 3, 4, 4, 5, 5, 6, 6. And it's quite obvious because this column is equal to the sum of these digits. If I want this digit, I just add up all these and I get this. And yeah, if I want this digit, I add up these ones, I think. It should work. And if I want this one, I add up these ones. And if I want this one, I add up these ones. If you want this one, you add up these ones. So yeah, it's actually a 1 that goes over here. I wasn't sure at the start because it made no sense. But it is a 1 that goes to here. That goes over here. So if you want, oh god, there's still a thing missing. Red. Basically, if you want any square anywhere on the grid, all you have to do, you can say 56 is equal to this, the sum of those. 36, 46, 52 plus 4, 56. If you want another way of getting 56 is this, 55, 56. And yeah, it's always going to work. But then you're like, well, how can it be hard to find the rule for a column if all you have to do is adding these up? You just find a way to add them up. Yeah, well, for the first one, it's you can write it as the sum of 1 from 1 to n. And it's going to, I mean, no, what am I saying? This one is always going to be 1. And this one is going to be the sum of 1 from 1 to n, which is going to be equal to n. And this one is going to be the sum of 1 from 1 to n from 1 to n minus 1. So it starts to get insanely tricky. But if you want to do the sum of all from like 1 plus 2 plus 3 plus 4 plus 5 blah 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 plus n, and you stop at n, it's going to be equal to n times n plus 1. But since you stop at n minus 1, because you don't go all the way up here, you stop here, it's n minus 1. It's hard to explain, but whatever. I don't think I have to. Well, actually, no, it's not hard. Basically, if you have n plus 1, and then you change n equals n minus 1 instead, that's going to give you n minus 1 times n plus 1 minus 1 equals n times n minus 1. As you can see, because this is going to be n minus 1 times n, which is n times n minus 1. So there we go. That's how you prove it really quickly. And then it gets really, really, really tricky for the other one, so I won't even get into it. But basically, yeah, you just have to build Pascal's triangle, go to whatever amount of kills you're at, whatever amount of whips you're at, enter the rule for that column. If you can probably find it. You can find it on Google for sure. Um, you can even go probably on wolframalpha.com. Let me try to enter 1, 4, 10, 20, 35, 56. 1, 4, 10, 20, 35, 56. I don't know if he's going to find it. Possible sequence identification. There we go. This is actually right. This is right. This is correct. So the next term, you just replace your n differently, and this is the sequence: 84, 120, 165, 220, 286, 364. These are the next terms to come. And if you want and a different one, you would have to build. Let's say enter 1, 6, 21, 56. I don't think maybe he doesn't have enough digits. I think he has enough digits, but I'm not sure. Then it would continue like this. Oh, this is actually pretty cool. 2002, 3003. That means there's a 1000. That means there's a 1001 in the Pascal's triangle. What normalized vector? I don't know what that is. But yeah, this is pretty cool. So you can just find the rule for x equals a by using this. You draw your triangle all the way up to where you can find the sequence that you can enter in here, and he will tell you what the rest of the sequence is, or what the rule of the sequence is. And now let's just get into more of probabilities rather than mathematical rules. Let's go like this. So we said, let me take this. Oop. I don't even know what I did. I did Control X, I think. That's strange. I didn't know that would do that. Let's put this over here, and let's take this. Okay, now we can talk about probabilities, which is way more fun. No, actually, it's not more fun. They're both equally fun. So we said, if you don't agree that this is true, just get out. Get out. I don't care. If you don't agree that these statements are true, well, you can't understand. You cannot possibly have an IQ over 100 if you don't understand this. So just get out. So this, let's write it as when is the chance of having a whip equal to 50%? Let's say chance, this is what I was arguing about last video, chance of having one whip or more. What is the opposite of having one whip or more? Well, it's having 0 whips. So you want when this is equal to 50%. You want to find when is it equal to 50% my chance of having one whip or more. People were telling me 512 kills. They were saying after 512 kills you would have a 50% chance of having one whip because it's 1 in 512. But since we can say that the chance of having one whip or more plus the chance probability rather I'm French, so sorry. Oh, now this looks quite bad because it's not in a line, but let me try to fix it. Okay. We can say this is clearly equal to 100%. You cannot possibly say this is not equal to 100%. If you don't have 0 whips, you have one whip or more. How could this not be 100%? This is the most basic statement anyone could ever make, okay? So now, since we are looking for this term, and we have a way to find this one. So what we want is to express this in a number so that then we can find the value for this. Since we can now say that, let's call this probability 1 plus. This is going to be the probability of having one whip or more, plus probability of having 0 whips, which is 511 divided by 512 to the n, equals 100%. And then all you have to do is put this on the other side, and then yeah, you just solve it. So if you want the probability of the chance of having one whip or more to be equal to 50%, well then surely this is equal to 50%, because this is going to be equal to 50%. So you have 100% minus x equals 50%. X is 50%. So yeah, this is just 50%. Let's just write it as 100% minus 50%, just in case someone is completely lost. So then you want this 50% to be equal to this. So you just say, well, 0.5, which is 50%, equals 511 divided by 512 to the n. And then what do you do here? Well, you do ln on both sides. Ln of 1 divided by 2 equals ln of 511 divided by 512 to the n, which gives you ln 1 divided by 2 equals n ln 511 divided by 512. If you don't know your ln properties, get out. This is right what I just typed. You can, if you have like something to the n in an ln or in a log of anything, you can take it out, multiply it by that, and you can think about it. It is absolutely right. It makes perfect sense. And then you just have to say n, which is what you're looking for, equals ln of 1/2 divided by ln 511 divided by 512. This is what I said in the previous video, and people were like, nope, 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 I'm stupid, I don't understand. And of course this calculator doesn't have, but it doesn't matter. It doesn't matter if I use ln for this or not. Basically this, if you do ln in base a of, well no, I meant log in base a of x, divided by log in base a of y. It's equal to log in base like f, log in base f of x divided by log in base f of y. And it's also equal to log in base y of x. Whatever constant you use for your logarithm, we are using e, as ln is log in base e. You will always get the same. If you divide, if you use the same base, you will always get the same result. The base can be anything, but ln is the most commonly used one. So yeah, I just wrote ln, but it doesn't matter. It could have been anything. You can even put log in base 1/2 if you want, which could be useful, and then you would have log in base 1/2 of 511 divided by 512, and you would still have to do the same thing I'm doing. So it doesn't really matter, but let's just do basically 1 divided by 2 log divided, oops, didn't do divided, 1 divided by 2. This is ln, isn't it? No, never mind. For a second I acted stupid. And you get this. This is this is n. This is the n for which this equation is true. 3, 5, 4, 4, 5, is it something like that? 5, 4, 5? 5, 4, 5, 3, 5, 4, 5, 4, 5. There we go. Kills. This is all that I tried proving in the previous video. And then, I don't know, people didn't understand, I guess. This is very simple. I could have made this video a lot shorter to make this, but I also wanted to talk about multiple probability of having multiple whips, which for 2 we have right here. If you want the probability of having 2 whips, oh, even better, even better. Now that we have now that we're able to find the probability of having 1 whip, we can even say that what's the probability of having 1 whip in... Okay, if you get an item after 1000 kills, you don't want to look for the probability of having 1 item in 1000 kills. You want to look at the probability of having no items in 999 kills. That's what's important, not the probability of having 1 in 1000. So I got my first whip at 3100, right? So what you want to do is 511 divided by 512 to the 3100. I got near like 3150. This is the like how unlucky I was. .233%. Like this. This is how unlucky I was. I was in this percentage of people who didn't get a whip after like this amount of kills. I mean, for every about 475 people that get their first whip, there's one person like me that gets his first after 3100. This is what I was trying to say. And if you want the if you want me to tell you what the actual probability of having a whip after 512 kills is, really easy. It's this, 63%. And this, never mind. But yeah, this is close to ln of 2, I think it should be. How would I do... Yeah, do I still have the page open? 693? If you do like 1 divided by 2 log divided by 1, 2, 3, 4, 5, 6 divided by 1, 1, 2, 3, 4, 5, 6 divided by 1, 1, 2, 3, 4, 5, 6. This is almost equal to ln of 2, 69314. Nope. And then 693.14718, and then here you don't have a 7. And if you do 511 divided by 512, oh, that's not what I meant to do. I meant to do 1 divided by 2 log divided by 511 divided by 512 log divided by 512, 692. So this is quite close, but yeah. The probability of having one whip after 512 kills, I mean having no whip in 512 kills, is 511 divided by 512 to the 512. And then if this is the probability of having, let's just go up here. I just said the probability of having 0 whips in 512 kills is this. And if you add this with the probability of having 1 whip or more is going to be 100%. So if you do 100% minus this, let's do times minus 1, and then add it to 100%. This is the probability of having 1 whip or more. 63.24%. Yeah, well, 63.25. It's not 50%, it's 63.25% almost, something. This is a big difference. And yeah, I wanted to talk about also the probability of having multiple whips. Let's just do it for like the probability of having multiple whips. This is going to be harder. I haven't really thought about this, and I'm going to make this smaller, put it over there on the side. Okay, let's see. Let's replace this by 2. Two, 1. Okay. Now, I don't know if we're able to solve this. Huh. You know what? This is gonna be the riddle of the video. Can you solve this? Because I just wanna do something else right now. I've been doing this for an hour or so, and I think this is quite a decent video. I talked about basically everything I wanted to talk about. But yeah, this is just like, I wanted to try to make logic out of this, but you just have to do it mathematically really and just enter basically the chance of having no, this is the wait, would it work? Yeah, it would work. If you have but when n equals 2, maybe this line is wrong, I'm not sure. Wait, no. This line is wrong. I forgot to divide by 2. This is what's wrong. There we go. Here I forgot to divide by 2. This is the rule of the... Oh, I just scared myself for a second there. The rule of this is divided by 2. The rule of this column right here, the third one, is n times n minus 1 divided by 2. Not just n times n minus 1. Oh god, I just scared myself. I was like, no. But yeah, I was actually almost right when I typed it, but nope, forgot to divide it by 2. If you have spotted it, well, good, but I will go and rectify you in the comments and say, well, go to 49 minutes and 50 seconds. Um, yeah. This is basically all I wanted to do. Let's just find the probability of having 5 whips and 5,000 kills. Wait, what am I doing? What am I doing? I don't even have the rule for 5. I was gonna do the thing for 2 whips. Let's just do the rule, the probability of only having 2 whips in 2,000 kills. Oh my god. Well, it's actually quite likely. You have a 15.34% chance of only having 2 whips and 2,000 kills. Well, I mean, it's only 2,000, and I didn't even have one. So yeah, that's going to be it for this video. I think I taught everyone everything they have to know about probabilities if they want to play RuneScape and complain about not having. Oh, this is another one. What's the chance of not having Corpet and 17.6k kills, even though now he got it? 3%. Yeah. I mean, one person out of 34 that's going to do this. Let me just times this by 34, almost 100. And if you divide by 34 and multiply by 33, you're further from 100. One person out of 34 that goes for Corpet is going to be more unlucky than Casey. Um, so yeah, good luck. Corpet is freaking rare as hell. So yeah, I think that's going to be it for this video. 52 minutes. I think I didn't beat my record for longest video. For most informational though, I did. Thanks for watching if you have.